Hi, in this lesson, we'll see the Wheatstone bridge. We'll look at it from basic principles. I will explain the basic principle of the Wheatstone bridge, how the circuit works, and how you can use it to measure small resistance. That said, let's get into class. Here is a typical example of a Wheatstone bridge. Basically, it contains a power source, which we have here. It contains resistors and also the galvanometer. Now, like I said in the intro, you can use the Wheatstone bridge to measure resistance, like Rx. Now, the principle here is this. When this galvanometer, we have a varying resistor. This is my varying resistor. The more I vary this resistor to the point where my galvanometer, begins to deflect at zero. At that point, the Wheatstone bridge becomes balanced. Then I can take the exact value of my unknown resistor. That is the basic principle behind the Wheatstone bridge. But before we continue, let's label each part of this bridge. I'll call this resistor here R1. Let's call this R2. Let's call this R3. Let's tag here E. This is B, C, and this is D. For this galvanometer to actually be balanced, these resistors across this arm, across my A, B, and C, will become proportional to the resistors across A, D, and C. Now, the potential at this point D and the point B becomes equal. So at that point, the Wheatstone bridge is balanced. Now, if I have this resistor, since resistor R1 is proportional to resistor R2, and resistor R3 becomes proportional to resistor X, if the value of resistor R1 is 1 ohms, and R2 here is 3 ohms, so for R3 to be 4 ohms, definitely Rx will be the same thing as 12 ohms. Now, let me show you how it works. The first thing I want us to do is to redraw this circuit. Now, look at it this way. This is my R1. Here is my R2. Now, let me tag this point here, my point B, and here also is my point D. So that here is my RP and here is my RX. Now I can take it now to source. So that here is my A and here is my C. If I have current flowing through the circuit, if the current is I, at this node, it should split to I1 and I2. Now for the balanced Wheatstone bridge, my R1, I1, that's the voltage across resistor R1, will be the same thing as I2, R2. Solve that equation 1. And my R3, because the same I1 will still flow through R3 here on this line, my R3, I1 will be the same thing as Rx, I2. Let's start this equation 2. So that comfortably I can divide equation 1 by equation 2. So that I1 R1 over R3 I1 will be the same thing as R2 I2 over Rx I2. I2 cancels I2, I1 cancels I1. Then I can conclude that R1 over R3 over R3 is equals to R2 over Rx. Then my Rx will be the same thing as R2, R3 over R1. Now let's put our figures in here. From this resistor, we have R1 to be 1 ohms and R3 to be 4 ohms. That means my R2 also is 3 ohms. That's 3 times 4 over 1, which is equals to 12 ohms. You can see that's 12 ohms. Let's take an example. I'll advise you pause the video at this point and try your hands on this example. Now, in this example, you see that if I have I flowing through this point, at this point, I'll still have my I1 and my I2. So that this could be, let me now rename my resistors. Obviously, even without renaming the resistors, I have an 100 ohms here, I have a 10 ohms here. From the basic principle, my 100 times I1 will be the same thing as my Rx times I2. That's our equation 1. And my 10 times I1, because the same I1 is still going to flow into the 10 ohm resistor when it's balanced, when the Wheatstone bridge is balanced, the same thing as 400 times I2. Like we did initially, we divide both equations. So that 100 over 10, here is I1 will be the same thing as Rx I2 over 400 I2. I2 will cancel I2, my I1 will cancel I1. So that 10 here will be 1, 10 in 100, I'll be left with 10. So I can now cross multiply. And when you cross multiply, you come with Rx to be equals to 4,000 ohms. Thank you. Equals to 4,000 ohms. With this, I hope you understand how to work with the Wheatstone bridge. In case you have gray areas, please do not hesitate to use the comment section. We'll be there to respond to your questions. Thank you for staying with us and see you in our next lesson. Just a tip before I go. In our next lesson, we'll be looking at the Wheatstone bridge in an AC circuit. To ensure you get that lesson, please do not forget to hit the subscribe button and the notification bell. Thank you and see you in our next class.